Assalamualaikum and hi. So now we look at 1.3 electric potential. So there are 6 learning objectives here as are shown here. So you can go through them. So the first one here is that we are going to look at the definition of electric potential. So electric potential is defined as the work done in bringing positive test charge from infinity to that point in an electric field per unit test charge. Okay, so what are we basically trying to do is you have a positive test charge somewhere at infinity, alright, somewhere at infinity, and you're trying to bring this charge to a region where you have electric field line. So you're trying to bring them towards somewhere you have electric field line. So whatever work that you have done to bring this test charge and you divide it by the test charge is what we call as the electric potential. Okay, so V here is the symbol used to represent electric potential. W is the work done, and Q naught here is the test charge. And then for this test charge, you must include the sign. Okay, must include the sign of the charge. So kalau charge kamu bersifat positif 2 coulomb, so kita pun cakap dia positif 2 coulomb. If it's a negative 2 coulomb, kita pun masukkan dekat sini negative 2 coulomb. So the characteristic, the sign of the charge must be included in this equation. Okay, untuk V dia tak sama macam F dan juga E. F dan juga E, for your calculation, you neglect the sign of the charge. However, for V, kita takkan neglect, kita akan ambil semua. Kita akan masukkan. So, V here can also be calculated using another equation iaitu KQ over R. So, you have another method here iaitu KQ over R here. V is a scalar quantity and it has a unit of volt ataupun joule per coulomb. Okay, joule per coulomb ini datang daripada work done, unit dia joule, charge, unit dia adalah coulomb, so dia jadi joule per coulomb. Ini from the first equation here. And V adalah memang common unit ataupun yang paling basic yang sentiasa kita guna for electric potential. So, let us now look at equipotential lines and surface. Okay, apa maksud equipotential dekat sini? Alright, by the word equipotential, dia membawa maksud kata same potential, equal potential, potential, sama potential. Okay, itu maksud equipotential. Okay, equipotential lines and surface maksudnya pada satu garisan yang sama, let's say you have these lines. Okay, setiap garisan ini, contoh kita ada satu metal plate. Okay, this metal plate bersifat positif. Okay, metal plate ini is going to give potential di sekeliling dia. Okay, this potential comes from this plate where every line here have its own potential. Okay, every line has its own potential dekat sini. Okay, potential setiap garisan ini, let's say kita panggil yang pertama ini adalah V300. Okay, and then yang ketiga ni kita panggil V100, let's say. Okay, so every line here have potential. And along the same line, maksudnya kalau kita ada dua titik, kita ada dua titik A sini, B sini, dan lagi satu titik C sini. Titik A dengan titik B akan mempunyai potential yang sama sebab mereka berada pada garisan yang sama, jarak yang sama daripada charge itu. Okay, itu maksud equipotential lines. Kalau surface pula, you are going to have a charge. Katakan kita ada satu positive charge dekat sini. Okay, positive charge ini akan mempunyai surface di sekeliling dia. Okay, sebab dia punya potential will be experienced in this radial di sekeliling dia in all direction. So, sepanjang circle ini kita akan ada potential yang sama. Itu maksud equipotential surface sebab dia adalah permukaan. Okay, so let's say kita panggil titik A kita duduk dekat sini, titik B duduk sini. Titik C duduk sini. And as you can see, your A and B are along the same surface. So VA akan sama dengan VB. Sebab mereka berada pada permukaan yang sama. So when you're along the same surface, you're going to have the same potential. When you're along the same line, you're going to have the same potential. Itu masuk equipotential lines and surface. Even when you look at the definition, dia cakap locus of points that have same electric potential. So surrounding dekat sini, around this locus you're going to have the same potential. Along this locus you're going to have the same potential. Alright. Electric field points in the direction of decreasing electric potential. Okay, apa maksud dia adalah electric field kamu ini akan point in direction such that the value of your potential is going to decrease. Okay, contoh, let's say you have kita tengok pada gambar raja pertama ini, this first one, you have plates dekat sini which has a positive charge. This is your plates with positive charge, and kita tahu when you have charge, you're going to produce electric field line. So electric field line for this positive plate akan keluar outward from the positive plate. Alright, so as you can see, ini adalah direction of electric field line. So dia kata electric field points, ini arah dia point, dia tengah point ke kanan dekat sini, in the direction of decreasing electric potential. Okay, so as you can see, the first line here has a value of 300 volt. And the third line here has 100 volt. So apa yang dia cuba sampaikan dekat sini adalah nilai potential kamu akan semakin berkurang in the direction of your electric field line. So the further you get, the smaller the value is going to be. Begitu juga untuk dalam surface. In the surface pun sama. You have a charge. Charge kamu bersifat positif, kita akan ada electric field line yang akan keluar daripada positive charge ini. Alright, this is the direction of your electric field line. So kalau kamu tengok bulatan pertama ini, the first one here, the red color one here, dia akan mempunyai potential yang lebih besar compared to bulatan yang ketiga dekat luar sini di mana titik C kita duduk. Alright, so apa conclusion yang kita boleh buat dekat sini adalah potential at A akan lebih besar daripada potential at C. Sebab it points in the direction of electric potential which is decreasing the electric electric field points in the direction of decreasing electric potential dekat sini. Alright. Okay, the dash line represent the equipotential surface ataupun lines lah. So whenever you want to indicate equipotential lines dan surface ini, kita kena guna dash line macam dalam gambar rajah yang diberi dalam nota ini. As you can see, the purple color, I think this is purple lah ke biru. Alright, let's say the purple color here is the equipotential surface. Okay, dotted line dekat sini adalah kamu punya equipotential, di mana yang color merah ini is your electric field line. Same goes to the uniform electric field. This dash line is your equipotential lines. So bila nak lukis equipotential lines, tak boleh guna solid lines, kena guna dotted lines sahaja. Okay, and then dia cakap equipotential surface always perpendicular to the electric field line passing through them. Maksudnya garisan equipotential kamu ataupun permukaan equipotential kamu must always be 90 degree to your electric field. So kalau kita ada electric field pointing in this direction, okay, kalau kita ada lines of equipotential, dia kena 90 degree. This is your 90 degree. If you were to have surface pun tak ada masalah. Permukaan surface kamu ini dia kena membentuk 90 darjah juga. So as you can see in the diagram dekat sini ataupun dalam lukisan yang Miss buat ini, kamu punya electric field line and equipotential surface are 90 degree to each other. Sentiasa 90 darjah. Tak kisahlah dekat mana kamu nak ambil. Begitu juga untuk lines. Always 90 degree. Okay. Electric field mere intense near the charge where the equipotential are closely spaced. Okay. Bila kita belajar electric field line, kita ada equation E is equals to KQ over R square. Okay. As you can see, this is a positive charge and your electric field line setengah keluar outward from the charge. kalau kamu tengok dekat sini, you are going to have a greater electric field near the charge compared to the one further. Sebab E is inversely proportional to your R. So as your R increase, your E is going to decrease. Therefore, kalau lebih rapat dengan kamu punya charge, you are going to have greater value. More intense near the charge. Okay, more intense. So, dia punya intensity lebih banyak bila dia closer to the charge. Ini garisan electric field. Ini disebabkan adalah sebenarnya sebab your equipotential are closely spaced. As you can see in this diagram, kamu punya dash line ini, dash line untuk bulatan pertama dengan yang kedua ini lebih rapat compared to kalau kamu tengok ketiga dengan keempat. The gap here has increased. Okay, so the closer they are, the greater the electric field. As they get further, the surface akan semakin jauh. Dia punya bulatan akan not equally spaced. Dia sebenarnya they are not equally spaced. Okay, jarak antara one another is not the same. Okay, alright. Since kita mempunyai electric potential yang sama along the same surface, alright, when you have the same potential along the same surface, if you were to move the charge from one point to another point, what happens to the work done? So, kalau kamu tengok, kita belajar definition of electric potential tadi adalah the work done to bring a positive test charge from infinity to a particular region of electric field. Betul tak? Ini adalah definition kita tadi. Bringing positive test charge from infinity to a point of electric field. Okay, so saya Miss ada explain tadi, kita from infinity you are trying to bring this charge into here, and then whatever work that you have done divided by the test charge, kita akan dapat potential dekat sini. Okay, so if I were to rearrange this equation, W akan sama dengan Q naught. Okay, V, I can get the work done. Rearranging this equation, I can get the work done. However, dalam kes sekarang, we are going to move the charge, the test charge from a known position to another known position. Bukan lagi dari infinity. Okay, bila dari infinity, jarak dia sangat besar, sebab tu kita neglect the potential at infinity. Kita assume dah tak ada potential dekat sana. Okay, so when they are very from a known position to another known position, dia punya equation akan jadi delta V. Maksudnya difference in the potential at that two place. Okay, perbezaan potensi di dua tempat yang kita nak kira itu. So contoh dekat sini, based on both figures, the work done to bring a test charge from B to A. Okay, so kalau kita tengok dalam diagram kita ini, kita ada titik B dan juga titik A. Okay, kita fokus pada surface dulu. Okay, your A is here and your B is here. Alright, let's say I connect this dash line to get a circle. You can see that the A and B are along the same surface. Mereka berada along the same surface. So, berdasarkan pemahaman kita on equipotential surface, we can conclude that VA is equals to VB. Maksudnya A dengan B dua-dua ada potensi yang tersendiri, tapi just because they are along the same potential surface, they have the same potential. Okay, so since you are moving it from B to A, okay, ini adalah initial position kamu to final position. So if we are talking about delta V, final potential minus initial potential. Okay, so VB minus VA. So your work done now becomes Q naught VB minus VA. It's just that they are along the same surface. Potensi mereka sama. VB minus VA jadi kosong. So you get work done is 0. Okay, the work done that you got here is 0. Begitu juga when they are in equipotential lines. So if you were to move from B ke arah A, awak tengah bergerakkan dia along the same line. Okay, so kerja yang kamu akan buat dekat sini akan jadi kosong. Seolah-olah sia-sia lah. Okay, seolah-olah macam there is no work done. Assume there is no work done. Even though you have actually moved the charge from B to tapi sebab work done dia adalah kosong, dia nampak macam kita tak buat kerja because you're moving them along the same surface. Okay, so as a conclusion, there is no work done moving a charge along the same equipotential surface. You have to remember that kalau mereka berada along the same equipotential, berada pada same line, same surface, kerja yang kita buat adalah kosong. It is because when you minus them, V final, ya Allah, saya cakap V final minus V initial, saya tulis pula VB minus VA. Okay, sorry tersilap dekat bahagian sini. VA minus VB. Kalau kamu tengok dekat sini, Miss tulis betul. Initial, ini final. Final yang kena minus initial. So, salah tulis, sorry. Okay. Where was I tadi? Yes. Why do you get 0 is because the potential at A and potential at B adalah sama. They have the same value. You minus, you get 0. Okay, so sekarang kita nak tengok by definition apa maksud potential difference. Tadi waktu I explain about work done along equipotential surface itu adalah kosong. Dalam equation work done along equipotential surface kita ada W is equals to Q naught delta V, where I have talked about what is delta V, which is the potential difference, which is V final minus V initial. Basically dia adalah work done in bringing a positive test charge from a point to another point in electric field per unit test charge. So contoh, kamu ada, this is an area of electric field. Okay, ini adalah kawasan electric field kita. Kita ada banyak garisan electric field dekat sini. Okay, ini adalah electric field. As you can see, it is written here, E here. Alright, so kita ada banyak. So this is the region of electric field. And then you place a charge here. This is your test charge. Okay, kita letak test charge dekat sini. So apa yang kita buat dekat sini adalah, let's say you initially place the test charge at point B, duduk dekat B. Lepas tu awak gerakkan dia pergi ke A. Okay, so the charge has been transferred from A to B. Okay, so when you transfer the charge from A to B dekat sini, what is going to happen adalah dekat titik B ini, dia akan ada potential dia sendiri, VB. And then at the same time, when it reach A, dia akan ada potential dia juga. So, if VA and VB are the electric potential at A and B respectively, then the electric potential difference between A and B adalah V final minus V initial, which is VA minus VB. Sebab initially it was at B, dia bergerak pergi ke A. So final kena tolak yang initial. Alright. So kita boleh come with an equation VAB is equal to WBA over Q dekat sini. Alright. Where VBA is the work done to bring the charge Q from B to A. So bila kita nak tulis potential difference V delta V, kita akan tulis V subscript final position, lepas tu baru initial position. However, when we are talking about work done, kita akan tulis initial position to final position. Okay, subscript dia tak sama dekat sini lah. Kalau potential difference, kita kena tulis final dengan initial. Kalau work done, kita kena tulis initial dulu baru final. So this one, they mean the same thing here. And then you come up with rearranging the equation. The work done to move the charge from B to A here adalah Q, potential difference between point A and point B. The unit untuk potential difference masih volt ataupun joule per coulomb. Unit dia masih sama sebab kita hanya tengah tolak potential with potential.